Welcome to my YouTube channel Ray the Cat, and today in the electrostatic section we will see some questions. Okay, so this first question is, in this the capacitor, the capacitance of the capacitor is 600 picofarad, and if we change it to farad it will be 600 into 10 to the power of minus 12 farad. Okay, and it is charged by a battery which has a voltage of 200 volt. Okay, so suppose that this is was the capacitor and it is charged like this with a battery of this 200 volts. Okay, this is C1. Okay, so and now this is connected to a uncharged capacitor which is of the capacitance of 600 picofarad. Okay, but it is the uncharged capacitor. Okay, so firstly here it is a charged capacitor which has a 600 picofarad capacitance, and this is now an uncharged capacitor which is having a capacitance of 600 picofarad. Okay, so there is a property in the uncharged capacitor. What is there? When it is connected to this battery which is having a voltage of V volt, so now what will happen when it is a uncharged capacitor? We can replace it with a wire, because the resistance associated with an uncharged capacitor is 0. So we can easily replace it with the help of a wire. But if it is a fully charged capacitor, it is having a infinite resistance, so no current can flow across it. Okay, so now we can, if we replace it with a wire, so now this will be the situation. Okay, this will be having a C1 and this will be having a V. Okay, so now this voltage V, what will be this equal to? Since another capacitor has a zero charge, okay, so we know that V is equal to Q by C. So Q1 plus Q2 upon C1 plus C2. Okay, since it is an uncharged capacitor, so this Q2 will be equal to 0. So V will be equal to Q1 upon C1 plus C2. Okay, so this V came out to be this Q1 upon C1 plus C2, and this is for the initial state when this is having a charge of Q1. Okay, so initially what will be the potential energy? The potential energy will be half C V square. Okay, so half into C1 into V1 square. So initially the V1 is 200 volt. Half into C1 is what? 600 into 10 to the power of minus 12. So initially this C1 was 600 into 10 to the power minus 12, and V1 was this 200 volts, and this final V1, how we will calculate? Q1 plus Q2 upon C1 plus C2. Since this Q2 is 0, so we can easily find the final voltage will be Q1 upon C1 plus C2. So like this we can find the final voltage, and the final, what will be the final energy? Half into C1 plus C2 into V square. So C1 plus C2 will be this U final. So this will be the final energy, and in this it was asked that what will be the difference in energies when it is having a normal capacitor, and when both the capacitors are connected with one which is having a zero charge. Okay, so like this how we will do. This is the concept by which we can do. Okay, so one more time writing the equation for this. So how we will write? Minus V plus Q1 by C1 plus Q2 by C2 is equal to 0. Okay, so like this we can write, but here this Q2 is equal to 0 in this case. Okay, so like this we will find what we can also find what is the value of V. Okay, and like this we can also find what is the value of V, but this Q1 and this Q1 will be different. Okay, so this is the concept by which we can find the delta U. Some of the questions say collision, linear momentum and center of mass. Okay, so here we will see some of the objective questions and you have to think the answer which will be there for the questions. Okay, so here the first question here is, there are two equations which are given, and here the first equation is the R vector is given as 1 by capital M sigma mi ri, which is the equation of the center of mass. Here mi is the mass of the one particle. Suppose that this is the space, there are various particles, and this is the capital R vector, and these are the small r vectors, r1, r2, r3, r4. So this is the ri. So these notations you have to remember, that these are the r1, r2, r3, r4, and capital M is the whole mass of the system, and sigma is the summation of mi into ri. Okay, and here capital M is the mass and capital R is the R vector. Okay, and here the second equation is alpha Cm ACM is capital F by M. Okay, so this ACM is nothing else but the acceleration vector. Okay, so we can we know that this acceleration is a vector. So acceleration with respect to center of mass is equal to force upon total mass. So this ACM is nothing else but the acceleration with respect to the center of mass. Acceleration with respect to center of mass. Okay, so like this we denote this. Okay, so this is capital F by M. So we have to tell in a non-inertial frame. Okay, so if the frame is non-inertial, so we have to tell that which of the following is correct, will be correct. Okay, so this will be correct or this will be correct. We have to tell if the frame is non-inertial. So suppose that we know that this is the frame. Okay, so like this we can represent this. So ACM or the acceleration vector with respect to the center of mass, how we will write? Acceleration with respect to center of mass. So we will see the system from outside. So acceleration with respect to center of mass. So suppose that center of mass is here of the system. So from here we will draw the acceleration vector. Okay, so this will be the acceleration vector from here, and this will be the force vector or the F external. So we can also write here is written as a F external upon capital M. So acceleration vector with respect to center of mass will be F external upon capital M. Okay, so we have to tell that if the frame is non-inertial. Okay, so which of the following will be correct? Okay, this is the capital R vector which is written in terms of the individual R vectors. Okay, in this non-inertial frame, but in this what is written, it is a complete equation from the outside of the system. We have not written this acceleration vector like first acceleration vector, second acceleration vector, third. We have written in this as a whole with the whole system. But in the non-inertial frame, this is a, we can say that this non-inertial frame is what? Non-inertial frame. In this we have to tell with the non-inertial frame which of the following is correct. This one is correct or this one. But in the non-inertial frame, this is non-uniform frame. Okay, so since it is a non-uniform frame, so for telling these type of vectors, we have to tell the individual. We have to tell the individual vectors of every particle or every particle of the system. Okay, so if it was the inertial frame, it is a uniform frame, so we can tell from the external that ACM is the F external upon capital M. But since it is a non-inertial frame or the non-uniform frame, we cannot write like this. So we have to write individually. So this one is not correct, but this one is correct. In the inertial frame, that capital R vector is 1 upon capital M or the whole mass into sigma of mi into ri. So like this we can write for this system. This equation will be correct, but this equation will be right for the non-inertial frame. This condition is there. If the frame is non-inertial, so this will be correct, but this will be wrong. Okay.